Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 7. A thin convex lens of focal length 10 centimeter and refractive index N1 that is equal to 1.5 is immersed in a medium of refractive index N2. In each of the following instances, we need to determine whether the lens will behave as converging lens, diverging lens, or a plane glass. So N1 is the refractive index of the lens and N2 is the refractive index of the medium outside. So we can write the lens maker's formula. 1 upon F is equal to N12 minus 1 multiplied by 1 upon R1 minus 1 upon R2. And I can further simplify it as N1 upon N2, that is the refractive index of first medium with respect to the second medium, minus 1 upon R1 minus 1 upon R2. This is the lens maker's formula. Now, for the refractive index of the medium outside, that is air, the focal length is given to us as 10 centimeter. So we can write 1 upon F in air, that is equal to N1 upon N2 minus 1 upon R1 minus 1 upon R2. And for air, N2 is 1 and N1 is given to us as 1.5. So I can write it as 1.5 minus 1 by R1 minus 1 by R2. And this is equation number 1. This is the value of 1 upon focal length when the air is outside the lens. Now the lens is immersed in some medium and that medium has a refractive index N2 that is equal to 1.2. So let me draw it again. This is N1 and this is N2 that is equal to 1.2 and N1 was equal to 1.5. So again I can write the lens maker's formula. So F 1 upon F in medium 1 that is equal to N1 upon N2 1.5 divided by 1.2 minus 1 upon R1 minus 1 upon R2. This is equation number 2. Now I can divide these two equations. So dividing equation 1 and 2. What I'll get? The focal length in medium 1 divided by focal length in air, that is equal to 1.5 minus 1 divided by 1.5 divided by 1.2 minus 1. And this complete second term, 1 upon R1 minus 1 upon R2, that will cancel out. So now it will become equal to 0.5 divided by 0.3 divided by 1.2. And further I can simplify it as 0.5 multiplied by 1.2 divided by 0.3. And it becomes 0.6 divided by 0.3, that is equal to 2. So I've got the value focal length in medium 1 divided by focal length in air is equal to 2. So from here I can find out the focal length in the medium. So focal length in medium 1, it will be 2 times focal length in air. And focal length in air is plus 10 centimeter. So in medium, it will become 2 multiplied by 10, that is equal to 20 centimeter. So this is the value of focal length in medium 1, when the refractive index outside is 1.2. So since the focal length is positive, I can say that lens will behave as converging. For converging lens, the focal length is positive. Now let's take part B. In part B, N2 is given to us as 1.5. So again, we can write the lens maker's formula. So 1 upon focal length in medium 2, that will be equal to N1 upon N2, 1.5 divided by 1.5 minus 1 upon R1 minus 1 upon R2. And here I can see that this will become equal to 0. So that will be 1 upon focal length in medium 2 will be equal to 0 multiplied by something. So that will be equal to 0. And when I solve it out, the focal length in medium 2 will become equal to infinity. So when you take the reciprocal of this, you'll get the focal length in medium 2 is infinity. And the focal length is infinity for a plane glass. So in this case, the lens will behave as plain glass. Let's take part 3. In part C, N2 is given to us as 2. So I can write 1 upon focal length in medium 3, that will be equal to 2 divided by 1.5 divided by 2 minus 1 times 1 upon R1 minus 1 upon R2. And this is equation number 3. Now I can take the help of equation number 1, that is focal length in air, and I can divide these two equations, equation 1 and equation 3. So what I can write? Focal length in medium 3 divided by focal length in air, it is equal to 1.5 minus 1 divided by 1.5 upon 2 minus 1, and this 1 upon R1 minus 1 upon R2 term, that will be vanished out because both the terms are having the same component and we can cancel it out. This becomes equal to 0.5 divided by minus 0.5 and divide by 2. So this will be equal to 0.5 times 2 divided by 0.5 with a minus sign. And when I solve it out, it becomes focal length in medium 3 is minus 2 times the focal length in air. Focal length in air was 20 centimeter. Sorry, 10 centimeter. It was given to us. So I can write focal length in medium 3 is minus 20 centimeter. And since the focal length is coming as negative, I can say that in this case, the lens will behave as converging lens. So in a nutshell, we can conclude this thing that when the medium outside is lesser than the medium inside, then it will behave as converging only. When it is equal to the medium inside, then it will behave as a plane sheet. And when the medium outside is greater than the medium of the lens of the material, then we can say that it will behave as diverging lens. And that's the answer for this question. Keep learning, keep practicing, keep excelling.